Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about parallel lines. Okay, before we get into parallel lines, let's talk about some things that we need to know before we get into parallel lines. First is a plane. Now, it helps to have more of a visual description of this, but let me do my best to describe to you what a plane is. So a plane is just a surface such that if we have any 2 points on the surface that are connected by a line, all those points of the line are also on the surface. Now, in reality, a plane is defined by 3 non-collinear points. So think about a tripod. A tripod creates a plane, and a tripod is a stable base because I have 3 points which determine that plane, which are connected to those 3 points. Now, a plane, like a piece of paper, is a 2-dimensional object, and it extends in every direction, in a 2-dimensional direction, infinitely. So it has length and width, and it extends lengthwise and widthwise in an infinite direction, but it does not have any depth. All right, coplanar points or lines or segments, or points, lines, or segments that lie on the same plane. So any line that we have, all the points in the line would be coplanar. Now, a line by itself doesn't, in 3 points, doesn't necessarily make up a plane. So if you can think of, let's say, a pencil being a line, and you place a piece of paper, the edge of the paper on that pencil, you can rotate that piece of paper, or that plane, around the pencil in 360 degrees. So there are an infinite number of lines, or an infinite number of planes that touch a given line. Now, a segment can lie in a plane, a point can lie in a plane, and if points, lines, or segments lie on the same plane, we call them coplanar. Non-coplanar points, lines, or segments are segments, points, and lines that don't lie on the same plane. All right, so let's talk about transversals and parallel lines. The transversal is a line that intersects 2 coplanar lines in 2 distinct points. So we have here 2 parallel lines, not that one that was just drawn, but 2 parallel lines here and here. And then we have our transversal, which intersects the 2 parallel lines at 2 distinct points. The interior region is the region that's in between the 2 lines that are intersected by the transversal. And the exterior is the region outside of those 2 lines. Okay. So let's talk about alternate interior angles. Alternate interior angles are angles formed by 2 lines and a transversal. The angles lie on the interior of the parallel lines. They're on alternate sides of the transversal, and they have different vertices. So there are 3 components. Angles lie on the interior of the parallel lines, so inside, so I can have 3, 4, 5, and 6. They're on alternate sides of the transversal, so 3 and 4 and 5 and 6, and 3 and 6 and 4 and 5. And they have different vertices. Okay, so alternate interior angles, in this case, the pairs would be 3 and 6, and then 4 and 5. Why is that the case? Well, 3 and 6 lie on alternate sides. They're on the inside of the 2 lines, so they're interior. They lie on alternate sides. They're on the opposite side of the transversal. And they have different vertices. So 3 has a vertice here, and 6 has a vertice here. 4 has a vertice with 3, and 5 shares a vertice or vertex with 6. So 3 and 6 would be a pair of alternate interior angles. 4 and 5 would be a pair of alternate interior angles. Right, alternate exterior angles lie exterior to the parallel lines on alternate sides of the transversal and have different vertices. Okay, so I have I have 1 and 2, 7 and 8. Those are exterior to the parallel lines. Now I have alternate sides of the transversal, so 1 and 2 and 7 and 8 could be pairs, but they also have different vertices. So 1 cannot share a vertex with 2, 7 cannot share a vertex with 8. So now I have 2 pairs again, 1 and 8, and then I have 2 angles 2 and 7. So they meet the criteria. They lie exterior to the parallel lines, they're on alternate sides of the transversal, and they don't share a common vertex. So 1 doesn't share a common vertex with 8, 2 doesn't share a common vertex with 7. Okay, finally, corresponding angles. Corresponding angles are 2 angles, one of which lies on the interior and one on the exterior. They don't share a vertex, they have different vertices, and they lie on the same side of the transversal. Okay, so I can say now that 1 and 5 are corresponding angles. So let's see if that works. One lies on the exterior and one on the interior. That's right. They don't share a common vertex, and they lie on the same side of the transversal. So 1 and 5 would be a pair of corresponding angles. 3 and 7 would be a pair of corresponding angles. I can say 2 and 6 would be a pair of corresponding angles. And my last pair would be 4 and 8. Those would be a pair of corresponding angles as well. So again, 2 angles, one of which lies on the interior and one on the interior, one on the exterior. They have different vertices here and here, and they lie on the same side of the transversal. So the blue on this side and red on this side, and then the yellow and green on this side.